Alright, skills practice 39. This is concentration. So for question number 1, first you're going to want to find the total mass of the mixture. So all you have to do is add the mass of, I believe it's salt, plus the mass of water to get the total mass. Then divide the mass of calcium chloride by the total mass, and you're going to multiply by 100 because you're finding a percentage. It's going to give you a decimal, so you need to multiply it by 100. So it's 45 divided by your total 365 times 100 equals 12.3%. Question 2. First, you find the amount of moles in 32 grams of salt, which they give you. So 32 grams times the molar mass of salt, which is 58.45, gives you 0.5475 moles. So hold on to the number. Then you're going to find the amount of moles in 278 grams of water, also given. So 278 divided by 18 grams per mole is 15.44. So there you have the amount of moles of water and the amount of moles of salt. You add those together to get the total, which is approximately 16 moles. Then for A, you want to divide the number of moles of salt by the total number of moles. So you have 16, and you have the number of moles of salt, which is 0.5475, which gives you 0.034. This is only a ratio, so you don't actually need to multiply by 100 and turn it into a percentage. For B, you want to divide the number of moles of water by the total number of moles. So instead of 0.5475, it's 15.44. So you divide that by 16, and now you get 0.966, and it's also a ratio, so don't multiply by 100. Question 3. Alright, so first you set up an equation using the decimal version of the percent number. So what you're going to do is take x, which is the amount of, I believe it was salt, over 400 plus x. The 400 is the amount of water you have. You don't know how much you have total because you don't know how much salt you have, so you add that plus x. That'll give you the ratio, and that equals 0.125 because they give you a percentage of 12.5. Then you just solve. So here you multiply both sides by 400 plus x, which gives you x equals 50 plus 0.125x. Then you subtract 0.125x from both sides, so you get 0.875x equals 50, and then you divide by 0.875, which gives you 57.1, and that's x. Question 4. So you're going to want to assume that you have 1 kilogram of water because they don't actually tell you how much water you do have, but they do give you the molality. So you're going to take the top, which is, no, I'm sorry. You take the bottom, so you have 1 kilogram, which is 1,000 grams, and you have the molar mass of water, which is 18, so you get 55.56 moles. Then you're going to divide the number of moles of salt by the total number of moles. So here's the amount of moles of here's the moles of salt, which is 3.25, and the total number is again just 55.56 plus 3.25. So you get 0.0554. So for part B, first you're going to have to convert the number of moles of salt and water into masses. So you have the moles of water and the moles of salt, and you take 58.45 grams per mole, which is the molarity of the salt, and 3.25 moles. Oh, you multiply that by 3.25 moles, and you get 189.96. And you also know you already have 1,000 grams of water. So then you're going to divide the number of grams of salt by the total number of grams and multiply by 100. So you know you have 189.96 grams of salt, which you just found, over 1,189.96, which is just 1,000 plus 189.96. Multiply that by 100, so you get 16%. Question 5. Convert the number of grams of NaPO4 to moles. So first, 83.8 grams divided by 163. Grams per mole. That equals 0.514 moles.